Okay, I'm ready.
Of all the intriguing concepts we know in mathematics and physics, there is one that pushes the boundaries of human thought. Infinity.
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 Infinity. Infinity.
It's infinity. Infinite.
And it's there. The idea of infinity has brought us to levels far beyond what our ancestors could imagine. Mathematicians like Ramanujan revealed that if you add all positive natural numbers, from 1 plus 2 plus 3 plus 4 and so on, the result converges to something astonishing, -1/12, also known as the Riemann zeta function.
The complex version of it, he showed that zeta of -1 indeed is equal to -12.
In the 21st century, the number surfaced in string theory, where Joseph Polchinski himself described the result as pretty odd. He said that this value plays a role in preventing collapse in what's known as the Casimir effect.
The strings move in a two-dimensional plane, and then they've got orthogonal directions, and there's 24 of these orthogonal directions, which is 2 times 12.
Some cosmological theories even suggest that the universe itself might be embedded in a higher dimensional hyperspace, possibly infinite in extent.
We would like them to be talking about the fact that the universe may be infinite in extent.
And across human history, spiritual traditions have been deeply shaped by it. The Old Testament describes God as infinite in understanding. In Islamic scripture, he is described as the first and the last, with perfect knowledge of all things. The Avatamsaka Sutra speaks of the infinitude of the cosmos. Pop culture has also explored this concept recently. The series Dark on Netflix plays with the idea of time as an endless circle.
Ich bin du.
What if this concept of infinity had never been formulated by ancient civilizations? What if the strange result of this did not converge to -1/12? Would our reality today be entirely different, since it becomes one of the fundamental findings in string theory? This concept takes us beyond conventional logic, because here we're faced with a mystery that emerges from ancient texts, and it reappears in modern science. So, what would our civilization be without it? Infinity was once regarded as a sacred as well as a metaphysical one, something the human mind could never fully grasp. The only subject consistently described as truly infinite was what most people today call higher power or God. So the questions about infinity are almost as old as humanity itself. But by the first millennium BC, infinity began to enter mathematics, especially in ancient Greece. Thinkers of the time were already fascinated by its strange properties. For Anaximander of Miletus, infinity was the founding principle of reality. He believed that from it arose an endless number of worlds that filled the universe. For Heraclitus of Ephesus, infinity was bound to time. That time has always existed and will always continue. It was through infinity that human beings could recognize their own existence. Of course, none of these ideas were supported by a scientific methodology as we understand it. They were part of natural philosophy, deep speculation rather than empirical science. And since infinity is first and foremost a mathematical concept, what better way to understand it than to bring it into tangible reality? So to do this, we turn to simple thought experiments. Here's the first one. If you have a single nail placed upward, like this, and you press a balloon onto it, the balloon pops immediately. Now, perhaps you add a second nail, and it takes slightly more pressure. Add more and more nails, and the pressure required increases dramatically. Eventually, with a full bed of nails like this, you have to push very hard to make the balloon burst.
That's a lot. See, that's a lot of pressure.
Now, why is that? It's pressure equals force divided by area. So with one nail, the area of contact is tiny, and the pressure is concentrated, and so the balloon bursts. With many nails, the area of contact increases, and the pressure on each point decreases. Now, if you take that all the way to infinity, the contact area becomes essentially continuous, a perfectly smooth surface, like a flat floor. At that point, popping the balloon becomes as difficult as pressing it against the ground. This is one way infinity reveals itself in our daily life. And the next one is what we usually find almost everywhere. Have a look at the visualization given by this function. Each term is a point on the unit circle rotating as theta changes. The first rotates with angular speed, 1, the second with angular speed, pi. Because pi is irrational relative to 1, the two rotations never line up in a repeating way. The result is an offset that never quite closes. And so it begins. The offset reappears again and again. If we speed up the simulation, the combined path appears to sweep over and become arbitrarily close to almost every region of the shape that is traced out. This is why the value of pi we use is always an approximation. The moment you stop calculating digits after a certain point, it ceases to be the true value of pi. The calculation of a circle's area will never be exact, because there will always be a small portion of the untraced part, even if you have to zoom in far enough.
Some infinities are bigger than others. The number of counting numbers, that's infinite. The number of irrational numbers, there are more of those than there are counting numbers. So these are orders of infinity.
So yes, not all infinities are the same. Or at the very least, there are countably infinite and uncountably infinite numbers. For example, there are more real numbers between 0 and 1 than there are natural numbers stretching from minus infinity to plus infinity. This can be demonstrated through Cantor's diagonalization theorem, which we won't delve into here for the sake of simplicity. And the digits of pi belong to this larger infinity. In fact, the infinity of digits in pi is bigger than the infinity of natural numbers. Let that sink in for a moment. You see the consequences? It means that every possible sequence of numbers is contained somewhere in the digits of pi. Your phone number, your parents' credit card numbers, even every phone number of everyone you've ever known. All of them must exist somewhere in the endless expansion of pi. Of course, we cannot point to exactly where each one occurs, but as long as the digits continue infinitely without repetition, those sequences are guaranteed to appear within this special number that is pi. There is another, more tangible proof of this principle using a different method, which we will explore later. It's more practical than this abstract explanation, so stay with us until the end.
We see objects that sent their light to us basically 14 billion years ago. How about objects farther away than that? There are surely objects farther away.
So it's possible that things are far distant.
We
They're
could
just
be
the
living
light-
in an infinite universe, but all we have access to is our little bubble. Every year goes by, the bubble gets 1 light year larger, and we see a little bit more of whatever universe is out there.
When most people think about infinity, they often picture abstract math. But as you've probably guessed, physicists run into it too. Two most prominent examples are black holes and the Big Bang. Both are places in our theories where quantities shoot off toward infinity. At the center of a black hole, general relativity predicts a singularity. This is where matter is crushed into a point of infinite density, so space-time itself bends infinitely. And likewise, when we trace the universe backward to the Big Bang, the equations also suggest an initial singularity. Again, infinite density and temperature packed into 0 volume. So in both cases, we find infinities hiding in our equations. And that's a red flag, because usually it means the theory we're using is incomplete. Just as Zeno's paradox was solved with calculus, physicists believe the infinities of black holes and the Big Bang might eventually be resolved by a better framework. Perhaps that is where a quantum theory of gravity, or the so-called theory of everything, will emerge. And so, to summarize, in a black hole, space effectively ends at the singularity and transforms into time. At the same point, time itself also exchanges roles with space. And in the Big Bang, time itself begins. There is no before in the conventional sense, only the unfolding of space and time from that point onward. This is where Roger Penrose comes in. His theory of conformal cyclic cosmology, or CCC, proposes that instead of time beginning once at the Big Bang, our universe is just one aeon in an endless chain. Each aeon begins with something resembling a Big Bang, and it ends in a stretched out, cold, and empty state. Penrose argues that if you conformally rescale spacetime, the end of one aeon can be mathematically aligned with the beginning of the next. So, in this way, the universe has neither a beginning nor an end. It's an infinite cycle of births and deaths of universes. So, in one sense, infinity signals a breakdown in our equations, but in another, it becomes a doorway to new interpretations of reality. In this model, Penrose's CCC, it's the very bridge between one universe and the next. Around 750 BCE, Zeno of Elea introduced a puzzle that we now recognize as one of the earliest confrontations with infinity. He attempted to show its physical impossibility through what became known as the arrow paradox. It goes like this. An arrow is released from a bow with distance d to its target. To reach it, the arrow must first travel half the distance, d over 2. Then, it must cover half of the remainder, a quarter of d, then half of that, 1/8 of d, and so on without end. The arrow must therefore complete an infinite sequence of steps. Somehow, according to Zeno, this looks impossible. How could the arrow complete an infinite number of tasks in a finite time? But fast forward centuries later, with the invention of calculus, mathematicians demonstrated that this infinite series actually converges to a finite value. In this case, the sum equals exactly 1, which means the arrow does reach the target. Both distance and time remain finite. But let's take this even further. What happens when we deal with a series that does not converge in this way? Like, what is the sum of all the natural numbers from 1 to infinity? Let's just take a moment to really understand this problem. Arithmetic tells us that infinite sums only converge when the ratio is less than 1, but this one clearly diverges. Would it surprise you if I told you that the result can still be expressed as this value? Click this video if you want to see the full breakdown of the derivation. The key lies in a more advanced method called analytic continuation, which extends the definition of infinite sums beyond ordinary arithmetic. So instead of adding terms directly, mathematicians use the Riemann zeta function. Yes, the same Bernard Riemann we've talked about a lot on this channel. So here's the visualization of the zeta function at s equals -1. You see, the sum of this formula as it goes to infinity is equal to -1/12. As strange as it sounds, that's exactly the same result if we approach it arithmetically. Again, watch the unlisted video in the previous card on the top right corner. Now, there's another thought experiment about infinity, called the infinite monkey theorem. We're definitely so psyched when we learn about this intriguing thought. Just a reminder, this took 12 coffees and 1 identity crisis to edit, so enjoy it. Suppose you put a monkey in front of a typewriter and let it type randomly for an infinite amount of time. In the first few minutes, it will just type random characters, unreadable strings, and very long, nonsensical words. Once in a while, you might see the word apple appear by accident. But eventually, after a gigantic sequence of gibberish, you can see there's more words start showing up. Words that really make sense in English. Then the nonsense continues again. But given enough time, it will eventually produce every possible sequence of letters. That means the complete works of Shakespeare, the lyrics of every song ever written, or even the exact paper Einstein once published. At first glance, this feels too absurd. You see, when infinity is involved, the odds change completely. Because with infinite time, every possible sequence will eventually appear. Even the super rare becomes inevitable. And here's the fun part. There's actually a real project online that simulates this idea up to a precision of 3,200 characters. It's called the Library of Babel. What it does is generate every possible page of text. You can write something like, "I went to school yesterday," and it exists there. Many times, in fact. You can even search for the first sentence of Einstein's paper and find that the sequence appeared on volume 31, on shelf 4, of wall 4, of hexagon, on page 7 of this book. Oh, and before I forget, you can check this website at libraryofbabel.info. And for those of you curious how such a website is even mathematically possible, we've prepared a full explanation. Again, check out the unlisted video right here. But the conclusion is that to sustain the website, you'd need about 10 to the 4,680 possible pages. That's an unfathomable number. And still, it's actually smaller than a Googleplex, the concept we talked about in an earlier episode. Here's an excerpt from Carl Sagan to refresh your memory.
10 to the power 100, a Google. If you think a Google is large, consider a Googleplex. It's 10 to the power of a Google. That is a 1 followed by a Google zeros.
If I were asked to add all these numbers together, my first instinct would be simple. The answer must be infinity. It turns out that's not the case. This is the same kind of reasoning that Ramanujan used when working with infinite sums. He showed that adding all the positive integers doesn't simply explode into infinity, but it can actually be assigned a finite value. If you want to delve deeper into the concept of infinity, I highly recommend checking out brilliant.org. They have courses that cover from the fundamentals of infinity like cardinality, Hilbert's infinite hotel, Cantor's theorem, and even the Koch snowflake. And what's more fascinating is what Neil deGrasse Tyson pointed out, that there are both countable and uncountable infinities. Brilliant actually explains the reasoning behind that concept. They really take these abstract ideas and make them crystal clear with interactive lessons. So Brilliant is a platform that helps you sharpen your thinking every day with thousands of hands-on lessons in a whole module learning and practicing across math, science, programming, data analysis, and AI. Get started for free today with brilliant.org/beyondideas and enjoy 20% off an annual premium subscription. Just click the link on screen or scan the QR code to begin mastering the deeper patterns of infinity. Everything that exists in the world, every physical thing, from the components that make up the earth to the objects in your home, is measurable. All of it can be counted. All of it is finite, even our time to live on this planet. But what if both of those, matter and time, worked according to the basis of infinity? What if physical objects behave the same? So let's explore this thought experiment. Suppose we have a perfect box, completely sealed so that nothing can enter and nothing can leave. We place an apple inside. Then we return after 3 years, and the apple has rotted completely. Bacteria have done their work, so clearly it is no longer food. Yet if you return again after 100 years, and with that much time, the apple has likely broken down into nothing but dust. But you see, the apple contains chemical energy, the same kind of energy you would gain by eating it or burning it. Over time, that energy is released. The apple in the box will eventually heat up to thousands or even millions of degrees across immense timescales. So at that point, the energy begins to fuse, which creates nuclear reactions. And given enough time, neutrons will decay into protons, and these will transform into other particles.
You could break atoms apart only so far and expect to get energy out of it.
So with infinite time, all the particles inside the box will go through every possible state. And eventually, they will have to reuse and reconstruct states they had billions of years before. Everything that could exist in the box will exist in that box, and each state will occur an infinite number of times.
In any finite region of space, like the observable universe that we now inhabit, there's a finite amount of energy, which is carried by a finite number of particles, And those finite number of particles can only be arranged in finitely many distinct patterns.
This connects back to the monkey theorem we discussed earlier. Every letter, number, symbol, and character in our world is finite and measurable. But when infinite time is applied, those finite elements repeat endlessly in different configurations. The particles in the apple will repeat their configurations just like the characters in the Library of Babel. And so with infinite time, there will inevitably be a moment when the apple, or a particular arrangement of its particles, is exactly the same as it was before.
You've got an infinite number of them, and then you will get everything that can possibly happen will happen.
This is the case when only time is infinite. But what if physical properties, or perhaps the universe itself, are also infinite?
If space does go on infinitely far, the particle pattern has to ultimately repeat.
Which means that somewhere unimaginably far away, there could be another Earth, another solar system, and the most staggering implication is that there could even be another version of you.
There'd be copies of us out
An infinite number of copies
out there.
An infinite number of copies
of us.
Infinitely many of us at very far parts of the universe doing exactly the same thing that this copy of us is doing.
Copies of me that continue and copies of me that die at any moment.
Anything that can happen will happen, and it will happen an infinite number of times.
The probability of this is close to zero, but as you've probably guessed by our explanations so far, even almost zero still carries enormous weight in the realm of infinity.
There are many ways the universe can be infinite. If it's in accord with the laws of physics, everything that can happen in an infinite universe will happen because the universe is formally infinite.
Pop culture has also explored this concept recently. In Avengers: Infinity War, Thanos pursues the Infinity Stones to achieve infinite control over time, space, reality, mind, soul, and power. Likewise, the series Dark on Netflix plays with the idea of time as an endless circle, where cause and effect continuously influence one another. Of all the pragmatic things we've discussed today, I think we shouldn't lose sight of the bigger picture. Infinity points us towards something that goes beyond every boundary, something that transcends the limits of the finite. It's often tied to the eternal nature of higher power, the endless cycles of existence, or the ultimate source of everything. As we mentioned at the beginning of this video, spiritual traditions have deeply shaped how we think about infinity. The Abrahamic religions left their own traces of this concept in each scripture, but Eastern traditions offer some of the most profound ideas about the infinite. The first one is a term called samsara, or the endless cycle of birth and rebirth. Every being is caught inside this wheel, pushed forward by actions and consequences that echo across lifetimes, and across different worlds and realms of existence. In that sense, samsara is the perfect picture of infinity. The second is nirvana, which means freedom from this very cycle. Nirvana is not about reaching the last stage of samsara, but about stepping outside of it entirely. It's described as the end of craving, ignorance, and suffering. So in simple words, it's liberation from the chains of actions and consequences. We can think of it like being trapped in a video game with infinite levels. Every time you lose, you respawn. So you keep playing, level after level, and there's never a final boss or a game over screen. Now imagine one day you realize that the point is not to finish the game, it's simply to put down the controller. That moment of stepping out of the game is freedom, not within the cycle, but beyond it. Of course, in a religious context, much of this might sound strange or perhaps borderline irrational, but that's the nature of spiritual texts. They exist, they're documented, and we can read them. Even if they don't match common sense, we can acknowledge them as part of the human way of grappling with infinity. And in a way, it closely resembles math we saw earlier. It doesn't feel logical, yet it's there, proven and worked out by Ramanujan and Bernhard Riemann. And the same goes for the digits of pi, or even the monkey theorem. Inside that endless stream, we could theoretically find everything, even the private keys to Satoshi Nakamoto's Bitcoin. Every possibility already exists, hidden within infinity's library, just like our reality now.
We don't know all the answers, so we don't know where the laws of nature came from. We don't know why the universe began in the way that it did, if indeed it had a beginning. So we don't know why the Big Bang was very, very highly ordered.
Some scientists say the Big Bang was just an accident. And if that's true, then we don't really know why we're here at all. It can feel absurd that any of this even exists. But if there's a purpose behind it, then suddenly the question of why we're here has a meaning.
So if the universe is eternal, and it might be, it might not have had a beginning, religion needs to operate within that framework. It is appropriate to think about what it means to be human. Just I would say it doesn't mean you can't believe in God or gods. That's not ruled out by science, but some stuff's ruled out.
Even those who trust mathematics completely know it can't guide every step. As physicist Stephen Hawking once said, "I have noticed that even those who assert that everything is predestined and that we can change nothing about it still look both ways before they cross the street." And maybe that's where infinity touches everyday life. When the consequences are real, we act as if our choices matter. We're navigating uncertainty while balancing reason with instinct. If you're still watching, drop this emoji right here in the comments so I know that you made it this far.